Hello, everyone, and welcome to a CIS mini lesson. Today, we're going to be talking about the spread operator from JavaScript. So why the spread operator? What's the purpose? Well, the reason why I wanted to bring this up is because, frankly, the spread operator can be a very useful tool within your programming. It's used for being a sort of a quick syntax for adding and combining iterables. So the way that kind of does this is by taking a string or taking an array value and breaking it up into sort of individual elements. So if you have a string, as we can see in this sort of use case right here, that if we have this string, as an iterable or as a value called name, a variable called name, and if I want to go ahead and I throw it inside of an array bracket and put this spread operator, what I see when I console log and actually see the output, I'm going to get each of those elements of that string individually separated and put into an array as directly as individual elements. This is really nice because you can be able to separate anything that you want out as long as it is actually iterable. Okay, now I have some examples that I want to, just a handful of examples, because there are many examples that you could use, but just a handful of examples that I wanted to kind of present how the spread operator can actually be useful. So here we've got concatenation. And I've got these two arrays here. This first one with some fruit I called produce. The second one with some more fruit I have called new produce. Now, if I go ahead and I use this concatenation, this normal concat method to be able to put the two together, I'm going to get something, well, in this case, the same actually as what I'm going to get with the spread operator. It's just written a little bit differently. So instead of having to remember this method, all we have to do is remember the three dots, this ellipse, if you will. So we can take both of the arrays that we want to add. We can use the spread operator to make sure that we're getting each one by element, and then we can output or get our full array as individual elements. If we check our console log, what we're going to see is each one of them is actually completely equal to the other. Now, the one note that I will throw in there is when you are using large data sets, it would be faster to use the traditional concat method versus using a spread operator. But for small data sets, things like this, it is actually faster to use the concat with spread. Okay. If we move on, next, we can look at doing a copy. Now, the strange thing about this is that if we were to just do, produce, if I take my produce, variable here, and I set it equal to another variable, this produce copy variable, okay? And then I go ahead and I try to push another variable of some sort, to that array that I made, this produce copy array. I have an output. If I go directly to our console here, we're going to see that I do have this array that was made, and everything looks kind of good on the surface. Now, if you're looking ahead and you're looking down below at the other console log, you'll see that there was some variation. Why is that? Well, because realistically, if we don't use the spread operator to make a copy, and we do use this sort of methodology by just doing a straight equals with an assignment operator, we end up where we are manipulating the original array if we are adding anything to it. So we're really actually working with the original array, even though we're working with the copy. Here with the spread operator, we take away that access to the original copy. So here we have produce one, which is going to be these three items. If we make the copy using the spread operator and then we push something to it, we go back over to the console, and what we see here is that we have our original array of three objects, or three items or elements. And in the second array, we have 4 elements. So this true and false is just to represent, are these two is the original the same as or is the original not equal to the copy? Because ultimately that's what we're looking for. And in the first case, no, they are equal. In the second case, they're not equal. So this is truly a copy that's being worked with instead of just a more or less a reference. Okay. If we move on and we check out expand, we can expand on an array. And what's strange about this is, now granted, we are going to be able to take that this produce array and add it to this expanded produce. But the trouble is, if we don't use the spread operator in this particular case, we end up with a situation like this, where we have our array. There we go. So what we have is our array, but we're taking in the array as an array. So now we almost have an array of arrays. And that's not really what we're looking for. We just want one single array with all of the items directly in it. So using the spread operator allows us to be able to get that access. And then finally, just a math sample here, which is I've set this numbers variable as an array, and it has all positive numbers except for 1. Now, the idea here is to try to find the minimum number that's within the numbers array. So we can use math min, and we can put numbers inside. But if we don't use the spread operator, we end up where we have our numbers where we're going to get an NaN outcome. Okay, we're going to get not a number outcome. And why is because we're not actually evaluating the whole thing. It's just not able to understand it correctly. However, if we end up where we use the spread operator, we can actually get at that -6, and that could be considered inclusive. So, we're getting this NaN because we do have that negative number. That negative number is not construed as a number ultimately, and hence the reason for the NaN. So, nonetheless, I hope that this is kind of giving you some insight into the spread operator. I hope that you take away the fact that it is purely a way to just really make things iterable on an individual basis.